There is a new gold rush happening on the moon. Nations from all over the Earth are racing to find one of the most valuable resources in the solar system. Something that will allow people to build our first off-world colony. Out of all the many space programs and private companies that are competing for lunar resources, you might be surprised to learn that India has taken an early lead. They were the first to arrive on the most coveted piece of lunar real estate. And what they found or didn't find will have a major effect on how we colonize the moon. In 2009, India made their first major discovery on the moon with a mission called Chandrayaan. This was a lunar orbiter that observed the surface from space, and it was equipped with a very special instrument provided to the mission by NASA, the moon. Monology Mapper, also known as M3. As Chandrayaan-1 circled the moon at an altitude of 200 kilometers, M3 was able to create this spherical map of the lunar surface. Each color represents a different mineral content, but most important are the blue areas at the north and south poles. That tells us that M3 detected the presence of water and hydrated minerals called hydroxyls in these locations. This was the first real evidence ever collected that would confirm the moon does have large concentrations of water in its surface. When NASA astronauts collected samples of lunar rock and soil back in the 1960s and 7S, scientists were able to find trace amounts of water. But when we say trace amounts, we mean very, very small amounts. At most, the Apollo samples returned about 200 microgram of water per gram of lunar soil. A microgram is 1/millionth of a gram. So to put that into perspective, to get just 1 kilogram or 1 liter of water, you would need to process at least 200 metric tons of moon soil, which would be about 15 dump trucks worth. Now, the reason why we're so interested in water on the moon is because someday we'd like to see people living up there for long periods of time. But in order to do that, they're going to need a lot of water to keep them alive. They'll also need oxygen to breathe and hydrogen to use as a fuel source, both of which can be extracted from water molecules. The vision for the future only works if we can find significantly higher concentrations of water in the lunar surface. And this map from Chandrayaan-1 tells us exactly where to look. That's why all eyes have been locked on the south pole of the moon in this decade. NASA, China, Russia, Europe, Japan, and India have all made it their priority to investigate the South Pole and find genuine evidence of water ice in this region. India was the first to arrive. In the summer of 2023, their Chandrayaan-3 mission deployed a lander named Vikram to the surface of the moon. It touched down in a region that the Indians have named Shakti Point, located about 600 kilometers from the South Pole on the moon's near side. If you are wondering what happened to Chandrayaan-2, it suffered a fate that has become all too common for moon landing attempts in the 21st century. Just in the past decade, 2 American probes made by intuitive machines, 1 Russian Lunar probe, and 2 Japanese moonlanders have all crash-landed on the moon. So, it's not exactly surprising that in 2019, India's Chandrayaan-2 suffered a communication failure during its approach to the lunar surface and also ended up crashing. When you look at the history of spaceflight, one thing becomes obvious really fast. Clutter is failure. Every object has to justify its mass, its volume, and its function. That's why I've been using Ekster's smart wallet. It's about half the size of a traditional wallet. But it still holds over 12 cards and cash. And you can access everything instantly with a single click. There's no digging, no folding, no wasted motion. It's built with RFID protection, sustainable materials, and it even supports a solar-powered tracker card. So if it ever goes missing, you can find it straight from your phone. It feels less like a wallet and more like a piece of everyday engineering. Streamlined, efficient, and designed around real use. Ekster applies that same mindset to travel too. Their vacuum packing bags let you compress your clothes and free up surprising amount of space in a carry-on or backpack using a small rechargeable pump or any vacuum. Same philosophy, more capability, less bulk. Right now, Ekster is running a Valentine's Day sale with up to 45% off site-wide. And if you use my code, the Space Race, you can get up to 65% off your order. Use the link in the description. Use code the Space Race and upgrade what you carry every day and how you travel. Of all the potential landing sites on the moon, the South Pole is the most difficult. The terrain here is rough and uneven, filled with craters and hilltops. This is nothing like those endless flat plains where Apollo astronauts explored decades ago. challenges of this environment are made even more difficult by the extremely low light from the sun. Because of the way the moon is tilted on its axis, the sun never actually rises over the South Pole. It only just peaks above the horizon like the first light of day. This ends up casting deep shadows into all of those craters and valleys that obscure much of the surface in permanent darkness. All of this really just helps to reinforce how impressive it was that Chandrayaan-3's Vikram lander actually made it down safely and became the first mission to explore the surface of the moon's South Pole region. Of course, the primary objective for Vikram was to find water, but it actually made one very interesting discovery along the way. It turns out that the moon is electric. The Indian probe found an unusually high density of charged particles moving across the surface of the moon, and as they move, the particles create tiny spikes of electrical energy, essentially sparks. The electricity arrives on the moon from two sources. The big one is our sun. During the 2-week-long lunar day, the solar wind deposits charged particles on the surface that slowly accumulate. But a large amount of the electricity also comes from the Earth. Our planet has a magnetic field that blocks the solar wind from reaching the surface, which is what keeps us safe from cosmic radiation. Instead, all of the charged particles from the sun end up getting trapped in the Earth's magnetosphere and then released into space on the opposite side of the planet in this kind of tail shape. For about 5 days each month, the moon passes through the Earth's magnetotail and ends up getting soaked in all of this concentrated radiation. The result is that the moon forms its own layer of electrically charged particles that extends about 100 kilometers above the surface and contributes to a very thin lunar atmosphere. It's only about 1/1,000,000th the density of Earth's atmosphere, very nearly a vacuum. But it is still there, and it is electric. The next major task of the Vikram lander was to investigate underneath the surface of the moon. The Indians included a probe that would be deployed straight down into the lunar soil. Its objective was to measure changes in temperature up to 10 centimeters below the surface. And this is where they found something very unexpected. To begin with, the temperature at the surface of the polar region was too hot, measuring 70 degrees C, when the team had been expecting to find a temperature of between 20 and 30 degrees. But then once they started measuring underground, there was an even bigger surprise. With each centimeter that the probe traveled, there was a dramatic loss of heat in the lunar soil. By the time they reached 10 centimeters of depth, the probe was showing a temperature of minus 10 degrees C. That is much colder than they expected to find. This tells us that the lunar soil, also called regolith, is an extremely effective insulator. Just a relatively thin layer can block an incredible amount of heat. And that confirms a long-standing theory that we can use regolith as a building material for a habitat on the moon that would be able to protect human beings from the intense temperature and radiation of the lunar surface. This is great news for our prospective moon base. But we are still missing the most important element, water. Now, to better their odds of finding water on the moon, India's Vikram lander deployed a small rover named Pragyan. This was remote controlled by scientists on Earth who used 2 cameras mounted on the front of the rover to navigate the rough terrain and examine a variety of samples while traveling about 100 m from the landing site. The rover used 2 instruments to figure out what was inside the regolith. One is an alpha wave spectrometer, which basically fires radiation in the ground and then measures how the alpha waves bounce back into the instrument. The second is a laser-induced breakdown spectrometer, which blasts the regolith with a laser and then measures the light emitted by the blast. Both of these combined give Indian scientists a very thorough look at all of the different molecules and elements driven over by Pragyan, and they find some really cool stuff. The regolith contains metals like aluminum, calcium, chromium, and titanium. It also found oxygen, which is a really good sign. And unexpectedly, the rover detected a large amount of sulfur. The presence of sulfur provides a glimpse into the ancient history of the moon and its formation into a solid body. You see, sulfur is associated with volcanic activity. And we would expect to find that in the darker regions of the moon that we recognize as ancient lava fields. But finding it here in the light-colored highlands of the South Pole helps to support the idea that at one time the entire surface of the moon was molten rock, with the leading theory being that the moon was created when a rogue planet named Theia crashed into the Earth over 4 billion years ago. and released a big blob of molten rock and metal into space that eventually became our moon. So India found some pretty cool stuff out there on the lunar South Pole. But the one thing they were not able to detect was any amount of hydrogen, which means that there couldn't be any H2O, no water. But what does that mean? If we go back to our global mineral map created by the M3 instrument and look at those blue polar regions, the hope was that there would be water everywhere, just like the map showed. But India's Rover investigation proves that this is not the case. And just to back up that finding, when China sent their Chang'e 6 probe to the south pole of the moon in 2024 and actually returned a sample to the Earth for further study, there was no water found in that soil either. Now, that doesn't mean there's no water on the moon. It just tells us that we'll have to work harder to find it. This means going down into the bottoms of ancient craters on the lunar surface. Because the sunlight only ever hits the South Pole at a low angle, these craters remain in permanent shadow, which means that water ice would have been able to collect in these low-lying areas for billions of years without ever being exposed to heat. This is promising, but also problematic. With this extreme cold environment reaching down to minus 250 degrees C and being totally cut off from solar power, we are talking about an environment that might even be too harsh for a machine to operate. This is why NASA developed an instrument known as ShadowCam. It was launched on board a South Korean moon orbiter called Dinuri, and it uses an ultra-high sensitivity digital camera to see inside these permanently shadowed craters on the lunar surface. The hope was that with the veil of shadow lifted, we would find something like crystals of ice lining the bottom of these craters, but that was not the case. This is the bottom of the Hermite crater as captured by ShadowCam. It's one of the coldest locations on the moon, and it is a really cool sight to see, but it also looks pretty much the same as any other place on the moon. No hidden secrets or precious resources to be found. Now again, that doesn't mean there's no water on the moon, but it does give us some pretty clear proof that water will not be an easy thing for future moon colonists to obtain. We will have to go digging for it in the darkest, coldest depths of the solar system. Not to be a buzzkill or anything. I mean, no one ever said that this was going to be easy. The more we learn, the more we understand the true scope of building a habitat for humans in a place where we were never meant to live. Nature already provided us with a pretty sweet home here on Earth, but it also instilled in humanity an unquenchable thirst for adventure and exploration. We've always found a way to reach the impossible places before, and we are going to keep doing that in space. Final words fade as music swells.